or 10 lakhs patients visiting in a month, then actually, to be frank, actually he can able to do the work. Actually, means for 1 lakh patients also he can give the report and he can do the analysis. But the difference is, he may not work fast because he is a human being, and he is limited to certain speed, and he is limited because we will get tired, and we may do errors also. That is a human tendency. But however, like if you employ this knowledge, and if you train a machine, okay, if you train a computer by incorporating suitable coding and using suitable algorithm, if you train a computer, so it can give even 1 lakh reports also. It can scan 1 lakh reports, and it can code and decode, and it can give the report whether it is positive or not. And in order to do that, actually some training, some expertise training, and some knowledge should be given to the computer by means of coding, by means of programming, right? So that machine learning programs can be incorporated with knowledge, and human can be replaced here with the computers. They cannot be completely replaced, but they can be trained, and that computers can be trained, and that knowledge can be utilized here. And similarly, there are various ways to solve the problem, right? For example, I'm in Warangal, and if I want to go Hyderabad, so in Hyderabad, especially some high-tech city, yeah. So like I can go from Warangal to Uppal, and then in the city traffic to high-tech city, or I can go to Warangal to Gatkesa and ORR to high-tech city, or I can go like in different ways, like from Gatkesar also I have some separate route to reach high-tech city, etc. So these kind of there are several solutions, but what is the best solution for me? Like if I think about, if I want to travel from Warangal to Hyderabad, the best solution will be like maybe if my output is the minimum distance, then I will see how many kilometers it is covering from Warangal to high tech city if I reach by ORR, and how many kilometers like I can reach if I go by city traffic. And if my output is less traffic and comfort travel, then also I have some terms and conditions. Yeah. So every individual will think in different way, right, to reach our destination. So we have intelligence, that's why we think about in what way to go, and in what is our better way, means to reduce the number of kilometers or to reach the journey comfortably. Because the human tendency actually to think and take decision. But machines also can do this job if the machines are properly trained. So how do we train them? That is what important. So we have several machine learning algorithms, deep learning algorithms to train the machine properly, so that the machines also will take a suitable decision and think like human when the purpose is required, when the need is required. Let us take another example. We all use washing machines, right? So we all use washing machines at our home. So if you observe, so washing machines will work intelligent. Sometimes, like if you overload, and if there is more dirt, okay, then the spin speed, RPM, and the detergent consume will vary, right? And if the load is less and the dirt is less, then the speed will vary. The speed will vary, and there is a function, like if you observe the rotation of drum. In sometimes like it is clockwise, in sometimes it is counterclockwise, and intermittently like it will take water. Okay, the quantity of water taking if overload, the quantity of water taking if less load, and the quantity of detergent it is taking when it is overload, and mainly the vibration and the speed of the rpm of the drum will be varying, because the washing machine will works based on fuzzy logic. Okay, so based on fuzzy logic, actually it will not take the boolean rule, it takes fuzzy logic, and it will act as an intelligent machine when the and take decision basically, and it has multiple decisions, like as yesterday's expert is discussing, like what happens in boolean rule. Like if the boolean rule, like if I ask you, do you have fever, then the question is yes, or the answer may be, sorry, the answer may be yes or no. What happens in fuzzy rule is yes, I have mild fever, I have low fever, I have medium fever, like that. I have 100 degree fever, like that. So there are some multiple solutions in the fuzzy logic. So that we'll discuss when talking about our case study, etc. Yeah, but the example is like how the machines should think, how the machines think like a human, and how it takes decision when the time required. Yeah, and this kind of like if you see like if you remember the movie Robo, right? In the movie Robo, actually it talks about artificial intelligence, machine learning, mainly about artificial intelligence, etc. And what the hero do with the robo, actually he will train the robo, right? So he will teach all human values, he will teach all human values to the robo, and he will teach all medical related medicine books, etc. So that's why actually robo will act as an intelligent, and it is trained to give the ideas about medical related applications. And as well as like after teaching human values, the robot starts behaving like a human, right? So that's what actually he may be exaggerated, but the idea is like when you train, when you train the machine, when you train properly, when you give intelligence to the machine in a form of coding, then the machines will think like human. So that's what we have so far discussed, and we have a lot of explanation about ai, ml, deep learning, etc. Yeah, so how these models are used, and in our case studies in various manufacturing applications, in finishing applications, etc. That's what an interesting thing we need to apply. Yeah, so let us come to our second part of our topic. So in the last topic, actually, we discussed on various finishing methods and how the parameters are explored, and how the finishing actually taking place, and how the machine will works, basically principle, etc. Yeah, coming to when you start doing experimentation. Okay, so when you start doing experimentation, we need to have a proper strategy of doing experiment, and we need to have a proper understanding of doing experiment. Then only our experimentation can be taken further, and our experimentation can be validated. Yeah, so for that actually there are various techniques to validate statistically, and also to explore various variables and to improve the design, etc. One of the technique is response surface methodology. So we all know response surface methodology comes under design of experiment concept. So where we try to minimize the number of experiments without compromising the quality. Actually, it basically works on generating, establishing the relation between the variables, input variables, with output. Okay, so when you establish the relation between So we can establish the relation between the input variables with output variables, or we can also say establishing the relation between the independent variables with dependent variables. Okay, so the outputs are generally dependent on the independent variables, and the independent variables will have interaction effect, individual effect, and main effect, etc. on the output. Yeah. So response surface methodology we can define as it is a collection of statistical and mathematical techniques used for developing, improving, and optimizing the process. Yeah. So this response surface methodology or any other method like Taguchi analysis, orthogonal arrays, or any kind of technique which is used for DOE like full factorial is generally used for developing, improving, and optimizing the process. It is used in the design, development, and formulation of new products, and as well as improvement of existing product designs. Yeah, so this can be used for improving the new products and as well as improving the existing products. Yeah. So before going to optimization, basically this RSM will works basically for improving and developing and optimizing, etc. How we can use RSM? So RSM can be used by using a software called, means like we can directly incorporate the equations, and all the equations are incorporated in the software and it's ready to use. The software called Minitab. Okay, in Minitab actually this response surface methodology is available, and also we have design expert software. Yeah. So I think most of the people might be knowing about all this DOE analysis, ANOVA, and design of experiments, etc. But idea is actually before going to actual artificial intelligence ML and before going to doing the experiments, okay, so we need to have a strategy of doing experiments. For that, actually, response surface methodology will helps you a lot. Will helps you a lot to frame a proper design for your experiment. So, what is optimization? Optimization can be defined in various ways, and one best way, like an act, process, or methodology of making something as fully perfect, functional, or effective as possible. Specifically, the mathematical procedures involved in this. Optimization characterizes the activities involved to find the best. Yeah. So optimization is not that easy subject. Actually, it's a vast subject. Whereas people are working on developing different optimization techniques, different algorithms, and a lot of knowledge is involved, and lot of statistical analysis is involved in automation. In this optimization, basically, optimization is used to find out the best. Yeah, everyone want the best solution. Everyone want the best solution, and they want to avoid the worst solution. And optimization will leads to make a perfect functional or effective as possible solutions, basically. Yeah, let us take one small practical example, how to make a best solution, and how optimization will help you to make or to give the best solution among the worst solution. Like a small practical example, like if you want to make a cup of tea, just if you want to make a cup of tea, then what are the input things, input we required, and what is the output we expected? Okay, let us take input. So we required water, we required milk, okay, and we required tea powder, we required sugar, we required one boiling time, right? So we required one stove and boiling time, etc., and other ingredients. Yeah. So these are the input parameters. And what is output? So what is the general output we expect? Good taste of tea. let us take first is good taste of tea. Next, second output may be good color with low sugar or something like that. Okay, there can be several outputs. Maybe third output may be good for health. It means that add suitable ingredients which for which actually it may be good for health. Now, what optimization do is actually it tries to find out the best solution. It tries to find out the best solution and try to minimize the worst solution. So what is the worst solution here in our example? The worst solution is actually the bad taste of tea and with low color, less means different color, and maybe that is a worst solution. And good best solution is actually good taste of tea with good color, with good smell, and with good which is good for health. Yeah. Now these we call it as dependent. Okay, these we call it as dependent variables. And these input parameters we call it as independent variables. Yeah. Now, in independent variables, now what like how do we optimize to make a good cup of tea? Then there can be several experiments we can do, and we can finalize, we can optimize for a best solution. For example, 1 cup of water, 1 cup of milk, 2 teaspoons of tea powder, and 2 teaspoons of sugar, and boiling time maybe 20 minutes, like that we can have an experiment. And if you change 2 cups of water, 1 cup of milk, and 3 cups of 3 spoons of powder, like that we can make one more experiment. Ultimately, like the combination of means the what is the level of water and the percentage of water or milk, and the percentage of tea powder we are adding, and the boiling time will reflects, means will gives rise, will depend upon, means will depend will acts as an independent variables, and which will affect the output, that is good taste of tea. Now what is the best solution means we need to have a optimum percentage of water mixing, and optimum level of milk mixing, and optimum tea powder, and optimum sugar, and optimum boiling time. And if you add other ingredients, etc., then there is a possibility of getting best output. Yeah. So to understand what are independent variables and what are dependent variables, and how do we get best output by means of by means of varying the independent variables, etc. Now we can also see one more thing here. So there is an individual effect and the interaction effect of the independent variables in any kind of experiment. Like for example, the water, like water, if you increase more than 2 cups, there is an like individual effect. Like if the water increases, actually the taste of tea and the color of tea may go down. And if the milk increases continuously, that sometimes the taste may be good and the color is also good, but it will different in it will different in some other effect. Yeah. And the tea powder increase may affect on the color. And there is also a combined effect if you observe. So water mixing with milk mixing with tea powder, and water, milk, tea powder mixing with sugar. Okay. So there is always a combined effect of the parameters, like how the parameters will combinedly affect, and how it will result the how it will result the output. Now there is one more point also to remember here, to see here, that is like if you are targeting only one output, what about the other outputs? So how do we target all the to achieve the three outputs, and what is the perfect solution for that? For example, I required good taste, and I also required good color, and it should be good for health. So if I target three outputs, then what is my input parameters and what are the levels of my input parameters I need to optimize to get a best solution. If you are not getting best solution actually, then we'll go for doing some by applying some optimization technique. Actually, we'll find out the combinations of water level, milk level, tea powder level, and other ingredients, etc., to get the output. And always, when you are decided inputs and outputs, means when you identify the factors, when you screen the factors, then the response surface methods will help you to optimize and identification of the design space, and also to statistically approve our data, to statistically prove our data that our data is statistically correct. Yeah. So there are different types of optimizations here, like we can do single optimization, multi optimization, etc. Like but we need to observe that we need to understand that which one is maximum the better, which one is minimum the better, which one is similar, like what are the outputs we required, and what is the basic idea behind it actually. So in order to generate the link, in order to generate the relation between these input parameters and output responses, we go using response surface methodology. So we have used this response surface methodology for abrasive flow machining, and that data I will discuss now, and further we'll move for A and ML in the coming slides. So this is what about optimization I wanted to tell. And strategy of experiment, whatever the experiment you are doing, either you are doing a small experiment or big experiment, either you are simply measuring the temperature by using a thermometer, or you are using any big experiment in your lab, or any experiment using a lathe machine, always we need to have a strategy of doing an experiment. So in the phase one, actually, first of all, we need to find out the known factors and unknown factors in the experimental status, and then you screen. So you screen which are vital and which are not affecting, not much affecting, and then estimate effects and interaction. So you need to estimate the effects, what kind of effect is, for example, in our example, like what is the water going to affect for your taste of tea, what is the milk content is going to affect the taste of tea, like that. And then make a curvature, and if no, then confirm, or if yes, then go to surface roughness methods. And in phase one, actually, we'll work on discovery of all the factors, and phase two is actually the breakthrough, where we work on experimentation, and phase three actually we work on optimization, and phase four is basically a validation. Yeah. So whenever you write a paper, also actually will perform, will first explain about the working principle, and then we go for pilot experimentation, design of experiment, and then validation or confirmation experiments, etc., and then we conclude. So like that, there should be a proper strategy of doing experiment, and different phases are given here for our reference to follow. Yeah. So we all know function, like in a response or phase methodology, we used to choose the response variables, and if y is equal to f of xi is nothing but here, like maybe x1 x2 up to xk, and we understand that y is the dependent variable, and x1 x2 and up to xk are maybe the independent variables, and it's a polynomial model. And we also observe that what are the independent variables and dependent variables while performing an experiment. So based on that, actually there are several designs we can use, like two-level factorial design, and optimal screening design, and there are several designs. Among that, actually, I have used central composite method for my experimentation, and how I have planned my experimentation, and what is the strategy of my experimentation, and what is the outcome, okay, and how I have done optimization, and how further I have like use AML techniques, and finally how I validated, etc. I'm going to tell now. Yeah. So the case study part I have already discussed the principle and various AFM hybrid variants, etc. I have already discussed in my first session. I'll directly go to the experimentation plan. So in the first phase of experimentation, a set of experiments were planned according to response surface methodology to finish internal surfaces using radial mode ultrasonic assisted abrasive flow finishing process. Okay, so in the phase 2, a set of experiments were planned according to response surface methodology for finishing internal surfaces using axial mode. Okay, so the change of mode in vibrating the workpiece is novel here, means it's that is different here to explore. In the third phase, a set of experiments were planned according to Taguchi orthogonal array to finish external surfaces. Like in the third phase, actually, using Taguchi is different, and also finishing external surfaces is different. Like that, I have planned 3 phases of experiments: phase 1, phase 2, and phase 3. Let us take phase 1. So the experimental procedure, before going to the how I have done the experiments, the experimental procedure, like for conducting experiments, I have used a two-way horizontal ultrasonic assisted abrasive flow finishing with hydraulic control. Yeah, and you can see the design of the setup. And like if I explain a principle, so we have an hydraulic setup here, hydraulic cylinder 1 and hydraulic cylinder 2, and we have media cylinder 1 and media cylinder 2, and we are pumping the medium from one cylinder to another cylinder passing through the target surface, right? And there are various parameters acting here, like the media is flexible in nature, and also media viscosity, media rheology, media flow rate, media flow volume is acting on this principle, and as well as the extrusion pressure, number of cycles, and the workpiece hardness, and the restriction of workpiece passage. There are several parameters acting during this to and fro motion of AFM process. Like we have already discussed on this in the before class. So I don't want to spend much time on this, but like I hope you understand what is the experimental procedure we followed. So we have used a semi-solid media and we pump to and fro, and parallelly we mounted an actuator here. Like you can see, we mounted a piezo actuator and we vibrated the workpiece by using piezo actuator and setup. Yeah, so this is what the experimental procedure. And what are the workpieces we selected? So for external finishing, this is a bevel gear, and for internal finishing, actually, we used EN8 specimen, EN8 steel, and as well as aluminum 2014 series for internal finishing. So these are the workpieces chosen for internal finishing and external finishing. And you can see the flexible media prepared in a laboratory uh, for different abrasive sizes. Like for example, 150 mesh size, this media is prepared, and 200 mesh size, 300 mesh size, and 400 mesh size. The abrasive particle used in this study is silicon carbide, and the polymer used is honeybee wax. So we all know honeybee, right? So honeybee wax. So there is a wax material, natural wax we get from the honeybee comb. So that is used. And also some ingredients were added for flexibility, for getting the flexible behavior of the medium. Yeah. So in this way, the media is prepared. Yeah. And you can see the chemical composition of the workpiece used in the study: aluminum 2014 alloys, and also EN8 steel used in the study. And the formulas used for measurement and calculation used in the study. Okay, there are two outputs actually: output 1, output 2. Yeah. So output 1 is actually delta RA. Delta RA is nothing but we are representing surface roughness in percentage. Yeah. So this delta RA will be higher the better or maximum the better, right? So we are targeting the maximum delta RA in our study. So for calculating delta RA, actually we are using this relation. So where you can see the initial roughness of the workpiece is taken and the roughness after machining is taken divided by the initial roughness into 100. So delta RA is my first output. And second output is material removal. So in material removal, actually we are not calculating the rate, but whereas we are calculating the initial weight of the workpiece and the final weight, and it is in milligrams. Yeah, so these two are the outputs we have chosen, and the remaining are, like you can see, the expression for response surface methodology and also an expression for signal to noise ratio, which I have used in phase 3. Yeah, coming to selection of process parameters and their range. So selection of process parameters, levels and range is very important when you choose a strategy, means when you choose your main experimentation. So while doing research or when our students working with us, so it's always important to set a proper design of experiment so that the student will not means struck in between. Now, how do we choose the parameters, levels, and how do we choose the proper design of experiment is what we learn basically from the literature. So basically the main idea will be from the literature, and also it depends upon the equipment we are using. Okay, the equipment and the conditions, etc. Based on that, actually will design some suitable experimentation. So in my setup, in my ultrasonic assisted abrasive setup, first thing is actually the novelty in the setup is applying ultrasonic frequency externally to the workpiece. So obviously I need to choose applied frequency as the variable parameter. I cannot choose it as a constant parameter because I need to verify, means I need to basically to understand the behavior of ultrasonic frequency, because it's a new parameter introduced in the study, and how the result will vary if I vary applied frequency is what important. And coming to other parameters, based on the literature and also based on the pilot experimentation, we'll get an idea which parameters are giving more influence. So like in AFM process, extrusion pressure will be the more influence parameter. Why? Because if you apply the semi-solid media at certain pressure, then only the finishing will take place. Otherwise, the finishing will not happen. Okay. So, and the third parameter I choose is abrasive mesh size. Yeah. So abrasive mesh size will have a lot of a crucial role, because if the mesh size increasing, what happens? If the mesh size is decreasing, what happens to our output? What is the trend to surface finish? What is the trend of material removal rate? So there is an influence. There is a lot of influence by changing the abrasive size in our media. So that is considered as the third independent parameter. And the fourth independent parameter is actually the processing time. Processing time is nothing but the number of cycles to see whether the process is rapid or not. Okay, to verify whether the process is better than the simple AFM, means without any ultrasonic, etc., ultrasonic features, etc., whether it is really worthy or not, whether it is fast or not, etc. In order to verify that, actually processing time is also chosen as one of the parameter. Yeah, coming to constant parameters, like constant parameters are decided by pilot experimentation. Like if you observe, some parameters will not give much influence in the overall experimental design. That parameters we keep it as a constant, it means that there is no interaction and there is no curve formation in these parameters. So at these particular points, actually we fix this constant and we make this constant parameters and then we continue. So like that in my study, actually media flow rate, viscosity, abrasive concentration, temperature of the media, initial surface roughness of the work pieces which I have chosen, and the amplitude is kept as constant. Of course, the amplitude is also newly invented, means newly involved parameter, newly established parameter in UAFM process. But however, my setup conditions, due to setup conditions, it can only give 10 amplitude. Only variation is 10 amplitude in my setup. So that's why I unable to explore it experimentally, but I tried to explore the amplitude and its variation in simulation. So that's what I have done when I was working on UAFM process. And my outcomes, there are two outcomes you can see here, that is delta RA and material removal. So this is my process parameters and their ranges plan. Yeah, coming to experimental data. So based on response surface methodology and by using central composite design, I got, say I conducted some 32 experiments on ultrasonic assisted abrasive flow machining. And what are my observations? I'll tell you based on this experimental study. Yeah. So A is nothing but here applied frequency. So I'm vibrating the workpiece externally. So like I have taken 4 levels. So you can observe here 15, 5, 10, and 20, and even in some places there is 0. Yeah. So I have verified applied frequency at 5 levels and extrusion pressure at 5 levels, like 2 to 23 bar, and mesh size at 5 levels, and processing time at 5 levels, within a range, etc. And these are my outcomes, which is higher the better. And MRR also, it's higher the better. Yeah. So based on the experimentation, my understanding and my analysis based on the experimentation is I achieve the highest surface finish at the last experiment. Like if you observe here, the last experiment. So that is 80% improvement in surface finish when I have used 15 kilohertz frequency and 7 bar and 300 mesh size as a, like used in the abrasive media, and when I machine up to 7 minutes of processing time, so I achieve 80 percentage improvement. Yeah. So coming to the second output, so my observation is actually, so I achieved the maximum MR material removed is 14.51 milligrams. So that is when the applied frequency is 15 and my extrusion pressure is 7 bar and the mesh size is 200 and processing time is 7. Yeah. So this is what actually I observed, and also I have observed the trend of individual effect of these parameters, and as well as I observed the trend of combine effect of these parameters. And if I show the results, I have developed a regression model, and I hope you all understood what this regression analysis and clustering in the previous lecture. So this is a regression equation I have developed, means I have created a relation between the independent parameters and dependent parameters, and this is the my regression equation for output 1, and this
Sir,
is
how you achieved this regression equation?
yeah.
From where?
Yeah, these regression equations are generated by developing a statistical model by using response surface methodology. Actually, these are calculated by using several formulas, and you can do in Excel sheet, but I have done by using Minitab software, Minitab, and sometimes Design Expert software. If you input this data, actually it will automatically generate this regression equations, regression model, and a lot of theory involved behind it. That will not go in detail much, but I will tell you like how I have used further and how AIML etc. will come into the picture. Yeah. So this is my equation one generated for source, and this is my second regression equation generated for output two. Yeah. So what are the things I achieved from RSM I'm telling, and further what I have done I will tell. Yeah. So this is like I observed like with zero ultrasonic frequency, what is the output, and by increasing trend of ultrasonic frequency, what is the output trend it is following. And similarly for output 2, without ultrasonic frequency and with ultrasonic frequency, how the trend it is following. It is following some increasing and decreasing trend. For that there are reasons technically. Yeah. Yeah. So like you can observe, so every the individual effect of the experiments which I have done. So the individual effect of code A, if I say applied frequency, and code B, like you can observe, it is following a trend. It is following a trend, an increasing trend, and this is my output one, and I can find out the optimum value for optimum value, like at which conditions actually we get more surface finish, and similarly extrusion pressure, and similarly abrasive mesh size. Like if you observe, the abrasive mesh size is not following the trend. Initially it was high and then it was decreasing and then again it is increasing. So the interaction effect is not good, and also it's not following trend, and we need to see what is the difference basically, when in what way it will affect, etc. And coming to the other parameter, processing time, like we can see the increasing trend. So this is one observation. And coming to combined parameters, like our example, like our practical example, like cup of tea. Similarly here, like if applied frequency is combined with extrusion pressure, so then how it will impact your output one. And if applied frequency is combined with abrasive mesh size, and how the result is going to affect that combined effect, etc. So like first we need to see, is there any interaction between these parameters. If there is an interaction, then we need to plot the combined effect of these parameters. So this is one study. Yeah. So next, similarly for a second output also, I have explored all the combined effect and then individual effect of all my four variable parameters. Yeah. Now and the data is also statistically correct, and the data is statistically significant. Now where is the issue? That's what I wanted to tell here. Yeah. The issue is basically the experimentation is done and the optimization is done, and also the relation between the independent parameters and output parameters ANOVA is done, and regressions models are generated. But however, like according to the analysis, like if you observe, my output one is reaching the target at the last experiment, like this trend, whereas my output 2 is best at this particular experiment. But I want the best solution for both the outputs, output 1 and also output 2. So that is one thing. And the other thing is, I wanted data which is not available in this table. So this is complete experimental data. And for doing one experiment, my manufacturing cost is something around 5,000, because the media cost is very high, and the acoustic emission means I need to vibrate the workpiece, and I need to prepare the media, abrasives, mixing the media is costly, and I need to work on three workpieces and should take the average of all the three workpieces, etc. Yeah. So the repeatability is somewhat difficult. Now that is one problem. And the other problem is also like I have the experiments For 15 applied frequency, 5 applied frequency, 10 applied frequency, 20 and 0. I don't have experiment when it is 2 or when it is 4 or when it is in between these values, right? I don't have an experimental data when I vary apart from beyond, like apart from these ranges. Similarly for B also, like I have data only for when the extrusion pressure is 17, when the extrusion pressure is 7, but I don't have data when the extrusion pressure is 10. Okay, so I can do the experiment, but it is taking a lot of time and a lot of money is involved, etc. But instead of doing that, instead of reaching this best solution, and like for reaching the multi-objective optimization solution, and also for predicting the data, actually I have employed first the fuzzy logic. I have employed the first fuzzy logic. Yeah. So what is fuzzy logic? Yesterday you had some brief about the fuzzy logic. I'll again repeat. Fuzzy logic is an approach to variable processing that allows for multiple possible truth values to be processed through the same variable. Like we have discussed the washing machine example. So the fuzzy logic checks for the extent of dirt and grease, the amount of soap and water to add, direction of the spin, and so on. So the machine rebalances washing load to ensure correct spinning. Else it reduces spinning speed if any imbalance is detected. Even distribution of washing load reduces spinning noise. Yeah. So this is like here the man is not involved actually. So based on the intelligence given by the knowledge system, the machine will work automatically and it will take decision. So like I also told like how it is different from Boolean rule. So I can say like if it is cold, so Boolean logic is if yes, 1, no, 0. Okay, if it is cold in fuzzy logic, yes, very less, little, very much. So fuzzy method is a method of reasoning that resembles human reasoning. This approach is similar to how humans perform decision making, and it involves all intermediate possibilities between yes and no. So that is what the major difference from Boolean rule. And like if you observe the fuzzy logic system, in the fuzzy logic system actually there is a fuzzifier, rule base, interface engine, defuzzifier, and the output. Yeah. So the rule base is actually to give knowledge to the fuzzy system. Yeah. So how do we give knowledge? Based on the expert knowledge available. So in my particular problem, how I have feeded knowledge and how I have done prediction, etc. We'll see. So yesterday you have already seen what is fuzzifier, defuzzifier, and you might have already working on this fuzzy logic system. So it's a rule-based system basically. So rule-based, so it contains the set of rules and if and then conditions provided by the experts to govern the decision-making system. Yeah. So this is what important actually. Provided by the experts to govern and the decision making system. So like in this way actually we need to give the if and then conditions so that it will gain knowledge and it will start taking the decisions. So on the basis of linguistic information basically. So recent developments in fuzzy theory offers several effective methods for the design and tuning of fuzzy controllers. Yeah. So here the definitions are given for what is fuzzification, what is interference system function, and what is defuzzification, etc. So fuzzification like convert inputs, and interference engine basically it determines the matching the function is actually fuzzy input with respect to each rule and decides which rule are to be fired according to the input field, and next the fired rules are combined to form the control actions. And defuzzifier is basically it is used to convert the fuzzy sets obtained by the interference engine into a crisp value. So that functioning already, I think yesterday you have seen. So basically how the knowledge is given to the fuzzy system and the role of interference engine, fuzzifier, defuzzifier, and how the output is framed, etc. We'll see. Yeah. So now let us see my particular problem, my particular case study. So how the fuzzy model has been helped to do the to predict the model and actually to minimize the repeatability and the experimentation. So the fuzzy model is used using a direct tool application from the MATLAB, and you can see the input functions and output functions are defined. So we call it as input and output parameters, and basically membership functions. Yeah. So A is here my applied frequency, B is extrusion pressure, C is abrasive mesh size, and D is processing time, and this is my output one, and this is my output two. So first we need to give actually ranges in input and output variables, because like if I, in the example, if it is cold means in boolean logic simply if it is yes 1 or no 0, but in fuzzy logic actually very cold, low cold, high cold, like that. In our case also, in my problem also, like applied frequency or ultrasonic frequency, I need to give the lower range of ultrasonic frequency, what is the outcome, medium range of ultrasonic frequency, what is the outcome, I need to see. I need to first fix the ranges, higher range of the ultrasonic frequency. Lightly I have stretched the band, like in the experimentation I have used only up to 20 kilohertz, but I have stretched the band up to 25 in the Mamdani in the membership functions for input parameters. Similarly, for extrusion bar also I have slightly stretched the band, and as well as I have defined low extrusion pressure, medium extrusion pressure, and high extrusion pressure. Similarly, it is done for abrasive mesh size and as well as processing time. And the next step is to define the membership functions for the outputs. So I have two outputs, and I have given the ranges like lower range, medium range, and higher range for surface finish improvement for my output one. So these ranges are similar to the experimentation what I have done, but slightly I have stretched my band to have more flexibility in the prediction data. And my output 2 is material removal rate, sorry, material removal. So I have given ranges for lower, medium, and higher. Yeah. Now coming to simulation block for fuzzy logic model. Yeah. So this is the fuzzy logic controller actually, where we give knowledge, where we train the controller. So these blocks are created in the MATLAB, and this fuzzy logic controller is feeded in the MATLAB, where the fuzzy tool is already readily available in the MATLAB tool. Yeah. So how to feed this fuzzy logic according to my problem? So what I have done is, so this is a fuzzy logic controller. I need to give rules. Okay, it's a rule-based system. If and then rules I need to feed, so that actually the machine will gain some knowledge and take decision, and also it will give the suitable information. And there is a system where it consists of fuzzifier, defuzzifier, interface system, and it will do its job and then start predicting the data. So how I have feeded the rules? So for that actually we need a expert data system. So let me go to my data. So this is the data I have with me before going to fuzzy model. Yeah. So like how to feed fuzzy system is what important. So this is my data. So how do I write the rules? So let me write one rule. So applied frequency is 10. So I consider applied frequency 10 as medium. Okay. What I will write is, if A is 10, means if A is M medium, then comma B is according to me, actually according to my ranges, 12 is also medium, B is medium, C is high, and D is low. Okay, according to my ranges, actually 4 minutes of processing time is low. Then my rule is, then the output one, which I got in the experimentation, is actually 52.28. According to my range, actually it is medium. Then the output one is medium, and MR second output is also medium. So this is my rule. So similarly, I will write a rule. I will write a rule for another experiment. Like if applied frequency is high, extrusion pressure is low, abrasive mesh size is low, processing time is high, then my output 1 is high and MR is very high. If I give category like high and very high, my MR is very high in this condition. And similarly, I will write rules like where the condition is 0. Yeah. So if my applied frequency is low or very low because it's 0, and my extrusion pressure is medium, and my abrasive mesh size is high, processing time is high, then my delta RA, that is output, is low. And similarly, my MRR is 10, I can say it is medium. Yeah. So like that, actually, we need to write n number of rules, maximum possible combination rules, by changing different, means by understanding the data set. We need to feed the information. We need to give the knowledge to the fuzzy logic system here. And after giving the knowledge, actually the fuzzy logic controller will predict the data, and after that, actually we need to go for validation and conformity. Let us say here my fuzzy logic controller, I'm giving, after feeding the data, so if I choose A as 3, means applied frequency 3 kilohertz, which I have not actually done the experiment. B is 5, means my extrusion pressure is 5, which I actually not done that particular experiment. C is 800. I have not used 800 mesh size in my experiment. D is, say, some 3 minutes. Then it is giving the data as your surface finish maybe 34, which is in low. Okay, and your MR may be 10.54, which is in medium range. And similarly, like I have used for A is equal to 17, B is equal to 19, C is equal to 400, D is equal to 9, then the surface finish is showing high, and MR is also showing high. Yeah. So like that, like after giving the intelligence to the fuzzy model, it is actually predicting the data. And the next step is actually comparing, means the validation. So how I have validated, I will tell you here. So there are 4 independent parameters I have chosen, and for 2 outputs, 1 output and output 2. And I compared, I have done 4 confirmation experiments. So these are the 4 confirmation experiments, means doing the experiment again. And then these are the experimental results. So these are the experimental results, actually worked on the experimental setup and using a regression equation. So I have shown you some regression equations before, right? Which I have developed for my experimental data. Like if I substitute A, if I substitute B, C and D in an Excel sheet, you will get some data, means you will get some predicted value for your delta RA. And if you change A, B, C, D, then you will get data accordingly from this regression model. So I have generated data for the regression model, and I have placed here. So this is my regression equation generated data, and this is my fuzzy logic controller data. So like you can see how close the data is. So in the experimental, I got 36% improvement. In regression, I got 37% improvement. Whereas in fuzzy, it is showing 34%. Maybe slightly some error is there, but it is somewhat close to the experimental data. Yeah. Similarly, in the other cases, like you can see, 55% improvement in second conformation experiment, whereas it is showing 53 in regression and 56 in fuzzy. So like that, we have calculated the error percentage, and observed that the error percentage is minimal, and it is less than 5%, and less than or equal to 5%, and it can be acceptable, and the model can be acceptable. So you can see the for output 1 and 2, you can see how close the trends of experimental data and fuzzy data and regression data. It means that actually the model which is predicted by using fuzzy model is is taken intelligence from the already existing data, and giving the prediction result, which is close to experimental. Yeah. So similarly, I have done, I mean, like by varying the direction of amplitude, I have done experiments. By changing the direction of amplitude, I have done the experiments, and same kind of application I have done. Yeah, that I will skip. And the next technique, in order to find out the best solution, I have chosen a new algorithm, not very new. Okay, it is first introduced in the year 2011 by Professor R.V. Rao. So the algorithm name is actually J algorithm. So there are several algorithms like genetic algorithm, J algorithm, Rao's algorithms, and teaching learning basic based algorithm, Topsys method. So there are various methods actually to find out the best solution and to optimize. And all these algorithms are generally machine learning algorithms. So what J algorithm, why I have used J algorithm is actually it is easy to use, and the computational time is very less, and the error percentage compared to other algorithms, it is very low. So that's what actually literature states. And I also tried using my data set, and I'll explain you how I have used my data set and how I have done applied this J algorithm, etc. So J algorithm is first developed by Professor Rao in the year 2011 for solving both unconstrained and constrained problems. J technique is applied with the help of MATLAB. Okay, I mean MATLAB coding is already available. Okay, we can change the parameters, and we can give the objective functions, and then we can generate the data. So, so basically the objective function is nothing but the regression equation. Means after doing the suitable number of experiments, we need to create a regression. Means we need to generate a regression equation by creating a suitable relation for our input parameter and output parameter. We need to for the polynomial model y is equal to f of xi. So after generating that equation only, you can go for further optimization, etc. So what the algorithm states? So algorithm basically states start, define population size. Population size may vary like you can vary the population size, like you can increase or decrease depending upon the computational time required and depending upon the quality of the results. Okay, define number of variables and the termination principle. And the second step is best solution. So find out the best solution and worst solution, define them clearly and evaluate it. How it is evaluated, that method you need to define. In the coding itself it is there. Yeah. So for my problem, what is the best solution? My output one is, so my output one is actually delta RA, right? My best solution is actually higher the better. Means whatever the value, means if I get 100% improvement, then that is my best solution. Okay. And what is worst solution? If I get 0% improvement, means there is no surface finish improvement even after machining, that is worst solution. So I need to give the best solution and worst solution, and then the coding starts. Okay, for this coding only actually the author is popular for, like how do you write code and how do you develop the algorithm, right? That's what. So the coding is basically in the Greek language. So he has, like in the next slide it is decoded also. So basically in order to generate a new variable, So this x is xi is a variable, f of x is the objective function. So in order to get the new variable, so it is given that, so old value plus random value, r1 is the random value, it is a randomly generated value from the 0 to 1, and best value, best output solution, minus mod of old value minus random value, and bracket open worst value minus mod of old value. Okay, the equation is written in such a way that your worst solution should be come out from the best solution. Means the algorithm will try to minimize your worst solution. And how the algorithm knows means you will define here clearly what is your worst solution and what is your best solution. And accordingly, the code which is given here will try to minimize the worst solution and will try to improve your best solution. And in the next step, it asks like, if the new value which is obtained from the random values generated is greater than old value, if yes, replace earlier solution. Means always the algorithm takes the best solution, replace earlier solution. If no, then keep the early solution and continue. Okay, so if the new value is best, then it takes the replace the earlier solution. Okay, if the old value itself was best, then it will keep in the old value and then continue. And the next step is the termination principle fulfilled? If no, then the loop will repeats. If yes, then the it prints the optimum solution. So like here you can see the extended version of J algorithm. Like you can see here, new value is equal to old plus R1, best value minus of mod of old value minus of R2 worst. So this taking away the worst value is what actually important in this algorithm. Like I have run this algorithm by using the algorithm codes which are already available on internet. Okay, like there are codes like, are you able to see my screen?
Yes, sir.
Yeah, so the codes are already available. Only the thing is, with the basic knowledge in Python and knowledge in using MATLAB. Okay, with these two things, actually, you can directly use these codes, and you can give our objective functions and our best solutions, our particular problem best solutions, and the ranges of our variables and the ranges of our outputs, etc. Okay, like after incorporating the changes, I will show you the results, how it is affecting my ultrasonic assisted abrasive flow machining process. Yeah. So if I open the result, like for initially I have done only for a single parameter. Means initially for only one output I have done. So A, B, C, D are nothing but my variables, independent variables. A is my applied frequency, B is my extrusion pressure, C is processing time, C is abrasive mesh size, and D is processing time. Actually, in the coding, it asks to give the ranges. So you can give the ranges, like for example, applied frequency, the range I have given is 0 to 20. So it will take randomly. It will take randomly the values. Similarly, for B also we can give the range. For C also we can give the range. For D also we can give the range. And F is actually the objective function. Objective function here is actually we have to incorporate our regression equation in the coding, and it will take automatically. Yeah, now if you observe, like based on the population size and the iteration, the code will determine what is best solution and the worst solution, because we are giving what is best solution and what is worst solution in the coding itself. And slowly it will improve the best solution, and also it will improve the worst solution. It means, for
Hello,
example,
sir.
yes,
Sir, in this case, it is the single objective optimization.
yes,
And if the two
Yes.
two objectives are required.
Yeah,
It is
yeah,
called multi-objective.
yeah. I'm coming to that. I'm coming to that. So I have done that also. Yeah. So first is actually I have tried with single objective. So slowly it is showing, it is minimizing the worst solution and it is improving the best solution. And finally it is printing the optimum solution. It is printing the optimum solution where actually you get the best solution. It means it gives the parameters your applied frequency should be 20, your mesh size should be 350, your extrusion pressure may be 2 bar, and your processing time may be 6. At that particular condition, it is predicting that actually you will be getting the best solution for one single objective. Coming to the second single objective, means that is my output 2. For that also actually, which is higher the better. For that also it is printing like which is best in the first stage and what is the worst solution. And similarly it is printing like you can see the improvement in the best. Okay, if the best solution is not improved, then it will replace the previous solution and then continue. So ultimately the loop means it will always take the best solution and proceed. So finally, what it is printing is like it is printing like if A is 20, B is 2, and if C is 150 and D is 8 minutes, then maximum material removal you can get maybe 19.11 if you use this particular conditions. But actually, I want maximum surface finish and maximum material removal. For that, actually, we need to go for multi-objective optimization. So in the multi-objective optimization also, only the thing is actually writing the equation F, right? So A, B, C, D will be common. So A is my applied frequency, B is my pressure, C is processing time, D is processing time. So these ABCD ranges will be common. Only while writing the equation F, here actually we will incorporate two equations, means my regression equation for surface finish and as well as my regression equation for material removal rate. So if I incorporate two equations and the symbols, minus symbol plus symbol are critical here. So you need to put for maximization positive and minimization negative, and accordingly you need to frame your equation, and it will also print the best solution for two objectives. So it is showing that if you use 20 kilohertz frequency, two extrusion bar, 350 mesh size and 8 minutes, it is showing that it will give the best solution for both the objectives. But at what time we need to stop the result? Actually we need to get the convergence. So here you can see how the process is getting convergence at number of what is the number of generations, and where actually there is no much difference in the result. There we need to stop the result. Yeah, similarly, like when you are going for multi-objective, when you are incorporating two outcomes, then there is a chance of weights adding. Okay, how do we add weights? For example, while writing the equation f of x, like objective function f of x minus f of x2. So while writing the equation, actually we can add the weights. So similarly, we have generated data by adding weights for delta RA 0.5 weightage and for MR 0.5 weightage. Then what is the outcome? So what is the surface finish we are getting, and what is the MRR we are getting, and what is the outcome? And similarly, if weightage is given more for surface finish, why it is required means mine is actually a surface finish process. I'm not much worried about MR, but my more priority is SF. So I will give more weightage to this and slightly less weightage to this, and I will print the solution, and it will show which one is best solution, and accordingly it is giving what are the parameter conditions I need to take. Like for example, 20, 22 extrusion pressure, 300 mesh size, and 8. So it is giving 0.77174 like that. And what is the surface finish achieved and MRR achieved for this particular problem? Yeah.
Sir,
So
can you please explain the weights again?
yeah, weights is basically for example, I have two outputs, no? Output 1 and output 2. So mine is finishing process. So I will give more priority for surface finish. Okay, I may give less priority for material removal, which is my output 2. So accordingly, I can give weights. Basically, it's generating data. That is one thing. And the other thing is actually giving priority weights, etc. What actually we are weights, giving weights means we are multiplying with zero point 0.5 into surface finish equation minus zero point 0.5 into MR equation. Then what is the outcome? How it is coming? Similarly, if I'm multiplying zero point 0.7 into surface finish equation and zero point 0.3 into MR equation, then how the result is coming? And zero point 0.9 into SF, zero point 0.1 into MR, like that, for generating data and also to observe the trend. So this is done basically. So like that actually we have done for magnetic abrasive finishing also, like whatever the techniques I have explained in my first lecture. For that also we have applied J algorithm, and then we observed, we also predicted data, like you can see the convergence graphs, and also we compared the data with genetic algorithm for even for magnetic abrasive finishing. And we found that actually genetic algorithm and J algorithm, there is slight difference. Like in genetic algorithm we got 78.72 delta RA, and 77 it is showing in J algorithm. And actual means for confirmation experiment, and actually it is 78.5, means this is actual experimental result, and this is the predicted data. So error percentage is actually 0.3% in generic algorithm, and J algorithm it is slightly high in this particular condition. It is showing 2% error compared to experimental data. Of course, if we do 4-5 experiments, it may slightly vary. The error percentage may be vary, and ultimately we need to compare the algorithms basically with what type of basically like what prediction model. Sorry, how much time, how much computational time it is taking, and what is the error percentage, and how simple the process is. Like that, there are several things we can compare, and we can choose the method accordingly. So this is what I wanted to share, and I would like to show some publications relevant to this particular case study. Like there is a paper on nano finishing methods. There is a paper, nano finishing, a new optimization algorithm for parameter optimization of nano finishing processes. Yeah. So in this nano finishing processes paper, like you can see here, the J algorithm code is the flowchart is explained, and then several objective functions were taken directly from the papers. Like for example, like you have written one paper, then you will define the ranges parameters, and then you will give the objective functions. Objective function is nothing but the regression equation, right? And the author has used directly the objective functions from the papers, like RA is equal to, this is the objective function, and the parameters bounds used in the papers, and then he has applied optimization here. Like here you can see this table is generated by the author. Like here you can see what is the RA they have achieved, and how much improvement can be done, and what are the parameters. The author suggested the parameters to use to get to achieve the required RA, to achieve the required MRR, and what is the computational time required in order to get the result. Like you can see how fast the method is. So like that, this paper will talks about various finishing processes and their convergence results, and how the boundary conditions or parameter ranges are taken, and how the objective functions are taken, and how this computational means work is done, means how basically this optimization is done. So this paper is about that, and there are courses available, and there are papers related to advanced machining using multi-objective Jaya. Like you can see the coding is slightly improved, and then they worked on multi-objective algorithm for optimization of modern machining processes. Yeah, so there actually you can see AFM also in this particular process. So they have used all modern machining processes which are recently published, and they have collected the parameters and their objective functions given in the papers, and then they have done this optimization. Means they are giving the data which method is suitable, means which parameter is suitable, and how to get the best solution. Like you can see here, parameter bounds taken from directly from the paper. So like they are referring the
Hello,
author
sir.
name. Yes.
Sir, on what basis weights are selected or chosen?
Yeah, generally weights are selected based on our requirement. And another thing is actually to see the trend, like if there is any change in the trend, etc. And to another reason is actually to generate more data and see the application, whether it is useful or not. So generally the weights are chosen by the person who according to his will, means but like whether maximum better or minimum better, etc. He need to decide, and accordingly he can choose the weights. Yeah.
If minimum is required, minimum weight selected.
Yes, yes.
If
Means
maximum is needed, maximum weight selected.
ultimately we don't know the trend, how the trend is varying. So you can have a trial by giving different weights, zero 0.5 one time and 0.9 another time, like that. Like if you have data for all the different combinations of weights, then you can decide actually which one is best. So to basically to generate the data and to see the trend. Yeah. So this paper is about modern machining processes. So in these modern machining processes, like the author has directly picked the regression equations, and then focused on performing the best solution and worst solution. And in some paper actually, like the author is also explained about how that x1 x2 f of x are calculated, and how the worst solution is defined, but best solution is defined, and how step by step procedure, basically how the step by step procedure of J algorithm is followed is explained in the papers. So similarly, like there are several papers published in several applications, J algorithm, and like if you see ANFIS model, so ANN and fuzzy model, so they have like computer science people have collaboration with mechanical people, and they have published in IEEE transactions, and the paper is about ANFIS model, prediction model developing for CNC milling. So as a mechanical engineers, actually, if you read the paper, we understand that actually we all know how the CNCs works, and basically how the material removal takes place in CNCs. And we also understand they have done some geometrical analysis using CMM, and like this all these CNC related things we can easily correlate. But what they have done is actually they have interfaced some machine learning algorithm, and they have done some data analysis, data collection, and some knowledge giving method by using ANFIS model. And that ANFIS model is predicting the data, and it is giving good results, and they publish the paper in IEEE transactions, like that. By incorporating AML techniques, by predicting the data, so we have a lot of scope in publications in various applications, basically. So here I wanted to conclude the session, and now if you have any queries related to the session, you can ask now.
Thank you, sir. Any clarifications from the audience?
So, someone asked like how we are measuring initial roughness.
Yeah.
Actually, we maintained initial roughness basically by choosing the process called reaming process. Like if I am working on an internal cylindrical bush, so I'm using reaming process. Like after boring, after drilling and boring, so we are using reamers to maintain the initial roughness. And after that, that micro level surface finish, we are improving to nano level finishing. If I am choosing flat workpiece, I am using grinding process to maintain the initial roughness. And how I measure means I can measure using surface roughness tester. So we have perthometer.
Any questions? Thank you, sir.
Yeah.
Thank you for your elaborate presentation on 2 sessions about the AI and ML application for the finishing process. Thank you very much.